So, the settings and the storyline. There was an advanced C++ course for undergraduates. On the fourth and final exercise, which, by the way, had a quite heavy weight, it was, I think, 60% of the grade of this course, it replaced an exam. They were required to implement something that I would present later on. And we were worried about the complexity, the task is a bit hard. So we decided to create a demo project, which is quite similar to the task, and to publish a solution to that demo project. The demo project, of course, was a bit leveled down. I mean, they still need to do something. The idea was mainly to practice them reading and using existing code, which is important, by the way. I mean, usually we teach and we let students write from scratch. And I believe it is important to practice them using existing code, because this is what we do usually in the industry. We read more than we write. So they could practice that. I mean, they need to read the example. And then they need to adapt it in a way in order to make it fit their own exercise. Then they can also learn good coding principles from the demo project, because we believe, at least anybody believes that his code is fine. We believe that we released a good demo project. I mean, we would look at the code and we would see that maybe we didn't release the best code. I mean, there were some pitfalls that they fell in, but we believed, okay, you can learn good coding principles, and you should. The transition from the demo project to the actual exercise seemed to us quite linear. I mean, well, you take that, we actually did that. I mean, I think that what I did, when I recall, what I did when I created the demo project is, I first solved their exercise. I don't do it every time, but I did that. And then I realized that, yeah, I'm a bit afraid that it is a bit difficult. Then I created the demo project, and then I leveled down the solution. So I did it, the opposite way of what they were about to do. But anyhow, I felt that, the distance is not too complicated. And then you would see that because we would discuss the exercise. But then we were a bit worried that it would be too easy. They would all get straight A's. And, teachers do not like to give all straight A's. So, but we couldn't do any much more about that because we already released the demo project and they go on. Well, we were too optimistic because juniors can be very creative with all sorts of surprising mistakes, and that was fine. And we were happy that we can grade the exercise and we can give meaningful comments that I would share with you. After the submission, we sent a questionnaire to assess with the students, did you actually use the demo project? And the answers, by the way, were all, yes, we did. So I will share that also with you. Then we analyzed the results. We didn't think about a paper when we began with, but eventually it became a paper presented at IEEE CS Education Conference, winning, by the way, the Best Paper Award. Let me brag a bit. This is the paper, and I'm not going to talk about the psychological parts, about the analysis of what was behind, but more to focus on the C++, or on the programming, or on coding by example. Okay, so we will be talking about coding by example and about juniors' mistakes. This is the timeline. They got the specifications, then about a week later, and it is not that they worked the project in that week. I mean, no student is getting an assignment, starting to work on it immediately. And we told them right away, okay, we think that it is a bit complicated. We would release something similar with a solution which would help you. So a week later, we released the demo project. And then they had 2 months. Why 2 months? Because it was towards the end of the semester. They granted a bit of, we have exams. So we said, okay, you can submit it after the exams. And then we had the submissions. And a week later, we sent the questionnaire after they submitted their solutions. This is the end of chapter 1. So we know the storyline. If you have any questions, this is a good time. Don't feel obliged. Don't ask me about, what about the example, or what was the example? We will deal with it in a moment. Okay, I see that there are no questions. So let's talk a bit about coding by example. Because in a way, we had the notion that they can code by example. I mean, they can take a look at an example and say, okay, we realize, we know what we are going to do here. And when we work with an example, I mean, do you work with code examples? Anybody here doesn't work with code examples? I mean, implementing his own code manually by himself, by herself, all the time? Nobody. We all work with examples, right? We search, we go to Stack Overflow, we find something, and then we copy-paste it. And this is what they do as well, without us giving them examples. I mean, students today, their first tool is Stack Overflow. In some cases, they use the tool by copying the assignment as a question, asking, anybody can help me here? You see these kind of questions. So yeah, they know Stack Overflow. They use code from Stack Overflow. And now they got another example. And this is one of the most common coding techniques today. Look for something similar elsewhere in my repo. I wrote it myself maybe, or the other team, I can find something, or I can find it on the web. And then you can either use the other code without copying. I mean, oh, the other code is a library. The other code is a function. I can just use it as a function. Or in some cases, take ideas and implement them in your own code. I mean, okay, I see what is done there. I would do something similar. Maybe I would copy a bit of snippets, or you can actually copy big snippets up to, okay, let's copy the 100% and have the same thing. Yeah, it ranges from I'm using it as is to I'm creating my own with snippets from this example. And they had, in a way, to decide what to do. I mean, they couldn't use it as a library because it was not a library, it was another exercise with some solution. So they should be somewhere here, either taking ideas or copying snippets, or doing nothing with the example, which was also something possible. Coding by example, then and now, then I mean 20, 30 years ago, I was still working, I look young maybe, I was still working with MFC, Precise, or Petzold on my table, you know, browsing through a book, and then when I had to take an example from the book, I had to type it. I mean, there was a CD. I could take the CD, put it, and look for the example, but no one has the time to. So I just, you know, type the example from, because I need it, and it's in the book. So the source was a book. Now the source is the web. When you used it, you usually manually typed it. Your involvement was a bit higher because, well, I'm in the book, I'm reading, I'm understanding, I'm typing. The involvement today is quite low. You know, copy-paste. The understanding while you're typing is higher. And in both options, you may have bugs. Like when you manually type, yeah, you may have typos. Typos usually are found by the compiler or by very simple tests. When you copy-paste, you would have copy-paste errors. Okay, these are quite different type of mistakes. Common mistakes while coding by example. By the way, the paper deals with this issue of coding by example, and this is not something new. There are papers on the subject, coding by examples. Our researchers went and sat near developers in their own environment, like anthropologists, and you know, they just like watching a lion in the savannah and watching what he's doing. Oh, he's copying, okay, he's copying He's thinking with his friend where to have lunch today. Okay, after an hour, he's back to the... So they document what is happening and they talk about how people are actually using examples. So code mistakes, not adapting the example to our exact needs, leaving unnecessary parts. I mean, it's like, you know, in evolution, we have unnecessary parts, right? Your code as well, because it was there. And I know something evolved, but nobody cut it. And we do not want to cut it. We do not, you know, open the program to cut something out just because it is not needed. Not aligning to targets coding standards, hurting conceptual integrity of our design. Ignoring better mashup possibilities. I mean, yeah, we can put it here. Whoa, it works. Yeah, there is another way to do that, but it requires me to look for another example, maybe, or to think. Not choosing the right example. Let's start with the XY problem. Are you aware of the XY problem? The XY problem is, okay, I have to solve something. I think that I have the direction for the solution, but I'm stuck somewhere. So my question is not about the requirements or my actual task, it's about where I'm stuck. And the problem is that my direction was wrong. So I may get a suggestion of how to go out from where I'm stuck, but the actual solution would not be good. I'm better off asking from the beginning. I mean, this is the task. How should I do it? Otherwise, you know, you go in the wrong way. So ask about what you want to achieve and not on, oh, okay, I know how to do this. The only thing that I have to do is this. I'm just, you know, lacking this part. Yeah, but you're asking me about something quite complicated while you think that this is the direction. Using an old code example. I mean, yes, it worked. You are copying C+98. You are not using move semantics there. Or you're using something that is deprecated, like throw parentheses, which is okay. You may get a warning and delete it. You may ask, oh, why did I get a warning? Ignoring better options. Taking the first example, or worse than taking the first example, and I see it. Taking the code from the question itself. I mean, you go to Stack Overflow. Oh, this is what I'm looking for. This is the title, exact same thing. Oh, I see code. I will take the code. And gosh, they scroll so fast. They scroll, I didn't have the time to read. I mean, and somebody, you know, put their code with some lines of comments and explanations and answer to a question. You didn't read anything of that. You just took the code, said, it seems right, put it there, but you know, there was some disclaimer, something said over there. There is more than one answer. They open 5 windows. They go to the first. It's not it. Wait, maybe you should scroll. No, the second scroll, here it is. 1 minute. I don't know. For me, it takes more time. But in some cases, they do take the right answer. In some cases. Anyhow, taking the code from the question itself is quite common. Mistake. Common mistakes, adapting the example wrongly or without a need. So in some cases, they have wrong intuition on certain parts of the code. I mean, okay, this seems like what we look for, but I don't think that I need lines 4, 5, 6. They don't do anything required. It's not in my requirement. Well, they actually check a corner case that you should check. I mean, you would find it out in production. Trying to be too cute. Oh, I remember that we can do that with. Well, you know, you add maybe a working example, and now we are trying to be too cute. You can be, but only if it has some reasons. Trying to adapt the code to the existing coding standards or design, but creating bugs along the process. We have fast and slow thinking systems. Daniel Kahneman, the psychologist, talked about that, Nobel Prize winner. Thank you, Matthias, he's sitting here, for bringing me this idea for the slide. The fast and the slow systems. When they embed examples Do you think that when we embed examples, do you think that we use the fast or the slow system? Well, I think that usually when we tend to embed examples, we use the fast system. I mean, yes, it seems right. Let's put it in. Let's run the code. It works. Let's continue. We have to hurry, right? While when we are writing our own code, we don't have any other choice but to think. So we're using the slow thinking system. Do we need the slow thinking system for embedding examples? I would say yes. I would say it is even more riskier. It is even riskier than writing your own code because you have to understand what you are planting there. Maybe you're planting breaches. Is an external code snippet a black box? I mean, we're used to modularity. Okay, this is external. I'm in the code review. Oh, these lines of code, what do they do? Oh, this is a regex. It finds something, and then it grabs something, and okay, and how this regex works, I don't know. I just brought it from the internet. Does it work? I think it was in the internet. Did you test it? No need to test it. It's from the internet. Well, I would say that the first thing that you need to do is to test the code that you are going to embed. By the way, my approach when I teach, when I do code, is when I open a new project, I tell my students, first, compile the project and run it. Because otherwise, it's empty, no line of code. Maybe main, in order not to have linkage error. So yes, you have int main, that's all. Compile and run. I want to see it running. Because in some cases, they come and say, okay, my code doesn't compile, I have linkage errors. Okay, when you started the project, did it compile? I don't know. I'm writing for an hour by now. Maybe your project settings are not right. And if we want to check it now, it would be more complex. Yeah, the idea is to reduce complexity. So start by checking smaller things. Start by checking the code example that you're taking before embedding it in and then checking the entire system. It's not a black box. Should an external code snippet be tested? Yeah, sure, it should. Even, I would say, more than your own code. I mean, your own code, you invested time in thinking about that, so at least you believe that it works. You should test it as well, but something from the outside. When it doesn't work, what would you do? Juniors tend to use trial and error. Trial and error are bad debugging practices, bad debugging practice. Why? Because it brings new bugs. I mean, oh, I checked it, oh, it doesn't work. In some cases, I just leave the thing that I changed because it's trial and error. I just, trying to move this line here, till something magically works. Did I understand what I do? No. Does it actually work? Well, the test that you currently tested works with the changes that you currently did. But you actually didn't understand what you are doing, so trial and error is not a good practice for debugging. Instead, you need to do the regular things. I mean, also on code examples. So in some cases, they take the example, and then they say, okay, I understand why it doesn't work. I have to cut this line, move this line. What is your theory behind that? Can you give me a, grounded theory of what you're doing? No, I'm just trying. It's not good. But it works. But it works. Well, you know that in C++, but it works is never an argument. It's never an argument. This code works. By the way, let's take a look at this code. We have a vector. We initialize it with 2 integers. We push back another third integer, and then we access the 4th element, which is not there. Can we write to the 4th index in the vector? Well, we cannot. It is not there. Do we have memory there? Well, it depends. Maybe the capacity is 4, maybe not. Suppose that the capacity is 4. Is it okay? Well, in integers, it's not okay, but it would work. With integers, if the capacity is 4 right now, what would be the size of the vector? 3, still 3, right? So somebody can come and say, but it works. Yeah, it works. By the way, it is not being caught by sanitizer. Sanitizer would not catch it. Why? Because I have the memory there, if I have capacity 4, right? Let's take a look. I have the link. I think that we can do that. Okay, so here is running with sanitizer. I'm with sanitizer, okay? And I have this vector of ints. I push back through integers, and then I access the, it's a bit small, but you can imagine that I'm accessing the 4th element, and the address sanitizer is very happy with us. Why? Because it's our memory. What can we do in order to make address sanitizer a bit more mad at us? Well, we can use another class, like for example A in this example, and A has a data member, which is a unique PTR, and then things do fall apart. So, eventually either your type would change or your capacity would not fit, and the bug would come out in production, right? So it works is not an argument in C++, right? Which is a problem, by the way, because me as a teacher, usually the best thing to say to a student when he asks you a question is, try it. But then he tries, and he says, yes, it works. But if it works, what does it mean it works? Well, try it, try it is good, because if it doesn't compile, then, well, you see, it doesn't compile. Why are you asking me? You can see that it doesn't compile. But if it compiles and runs, you cannot still be sure that it is good, that it is working, that it is legit. So, yeah, but it works. I don't know. A problem. And by the way, this is true for other software languages, but much more in C++. Because in C++, 7.1% of questions are answered with the answer, it's undefined behavior. Don't take me too seriously about this number. I just made it up. Anyhow, many questions are, no, it's undefined behavior. Or I think it is undefined behavior. So, examples are problematic, and they are a bit addicting. Because in some cases, you see it in code interviews sometime. You are asking a very simple question, and the guy on the other side, he is clueless, because he doesn't have the internet. It's a loop, right? Yeah, but usually for a loop, I use code complete. Write it down with a piece of paper. No, we are addicted in a way to IntelliSense, to code completion, to using, and there are Copilot and Tab9 and others who come along. Did you hear about these tools? You start typing, and then they'll say, oh, you're going to have here something like you are sorting. Let's drop the code. Let's assist you while you're coding by proposing what we think you actually are trying to achieve. And, oh, it wrote my code. The thing that we fear of is coming. No jobs for software development. No, it would not come. But anyhow, it tries to assist you. How many of you remember a phone number of a family relative? The phone number of your, only a few. Only a few. Maybe because in some cases you need to type it in your car and it doesn't work with a... No, how many of you can plan a 30-minute drive to somewhere by opening a map and getting the route and then getting on your way? So you can take a tour with them. Most of us, we just lost this ability. So in a way, I think juniors are losing the ability to work without the internet. I mean, a day without internet in the office is a day off, right? How can we write? We don't remember all, so let's take day off. But on the other hand, I'm not preaching for yes, write it, don't take it from the internet, don't use examples. Use examples, not invented here, is a bad approach. Do use examples, but we need to do it with care, right? So, a legal note, it's not only for language lawyers. This is a wordplay here. Anyhow, legal note, when you use code snippets, if it is more than a few lines, then you have to check the license, okay? It's not only if you are using a library, it's also if you are cutting, copying things from another open source. Oh, somebody sometime can see that, oh, this module was copied from a GPL open source, so our product is eventually GPL, and we didn't do it as a GPL, so we can be sued. So this is another thing that should be noted. So coding my example is more complicated than one may think. And a copied code snippet cannot be treated as a black box. And we do tend to do that. And students tend to do that, or to think like that.
Your example with the vector out-of-bounds access that wasn't caught by UB Sanitizer?
It was not caught by the sanitizer.
No, but there are UB Sanitizer is one of many runtime analytic tools that you can
like
use.
Static code analysis. Maybe static code analysis can catch that, yes.
It might do, but also if you're using GCC, there's a macro you can turn on and it'll add a runtime check to the standard library. There's a different one for Clang as well.
Okay.
In fact, there's one for MSVC too. So if you keep digging, you can usually, if it's really obviously a bug, you can almost always find some way to turn on a check that will catch it for you.
Thank you. So I think the comment is recorded because we use the mic, but I would summarize it. Yeah, there are other tools that can catch this error. Thank you.
So you mentioned that people using automatic code completion tend to start becoming reliant on it. Given that you're teaching to junior people who don't already have a basis of what they're doing, would you recommend them to use an editor that does not have code completion?
That's a good question. The question was, would I recommend starting with something that do not have code completion? So I would tell you I would not answer directly your question. I would start with something else. When I'm doing interviews, I prefer to do interviews without code completion. I mean, I want to see how you think. So write in Notepad, okay? Now with students, I do want to see this ability, and this ability comes in exams, by the way. In exams, they write code in notebook, pen and paper, so they need this ability anyhow. So yeah, they turn to teach themselves this ability of, yeah, we need to remember things and to use that. They grant about that. But what's the meaning of that? I mean, in real life, I would not write code like that. And I'm saying to them, yeah, you may be interviewed like that. So I do believe that it does, add something.
So with your example, you said you gave essentially a bug-free example, but then you start talking about how examples are usually riddled with bugs. Why do you not introduce a bug? So if you want to teach skepticism, teach it at the start.
If I get the question correctly, is if I preach against the examples, which I do not, then why did I give examples or an example to my students to assist them with the exercise? So first, I don't think that examples are bad. I think that examples are good. I think that we're using examples all the time. And I think that we need to teach them how to do that correctly. I mean, if they get feedback, this is much better than sending them out saying, okay, this is what you were taught, and all the rest, I mean, the critical bugs you would do in your job life, in your real life. So I think it is good to teach them how to use examples. And eventually, I believe that exercises and exams are part of the teaching experience. I mean, it's not only what you do in class. It's what they do at home. And in many cases, it's much more important. So dealing with the example and doing these mistakes is important because the mistakes are there and examples are there. So let's make them do the mistakes. And by the way, when they do that, either they see the mistake but do not have time. In some cases, it's time management. Or they don't see it, but they did get a very detailed feedback on their exercise.
Another source of problems from copying code from examples is that examples are frequently illustrative, so they will leave out aspects of the problem, typically error checking.
Yes, that's critical. So examples are illustrative. They assume single threading. They tend to neglect error checking, etc. And the reader should be noted about that. And our example, I think, had some of these issues. I mean, oh, but it wasn't the example. Yes, but it was only an example. And we told them that this is only an example. I mean, you should write your own code. You cannot come back and say, don't subtract any points for that, dear teacher. It wasn't the example. No, the example is, you should not assume that anything there is right. So thank you for the discussion and the questions. And we are to chapter 3. A few words about the C+ course. This is going to be a very short chapter. The course, this is a third-year course, CS undergraduates, non-compulsory, by the way. It used to be a compulsory course, and then it was turned to be non-compulsory, and the numbers went down. They start with Java and C, and then they come to C++ again as non-mandatory course. And I teach them the basic syntax, R-value semantics, templates, lambdas, containers, smart pointers, concurrency, multi-threading, and they get massive 4 code exercises. So we will deal with a 4th exercise, but the other 3 were on the same domain, but isolated, with multi-threading, with dynamic load of libraries, and many interesting stuff. Actually, in order to make them C++ programmers. So this is the idea. Following the talk that we had with Hannah this morning, 60%, I just calculated it during the talk, were women in this class. By the way, I just remember it vaguely. When it used to be a compulsory course, I think the numbers were higher. Well, it was compulsory means that all registered students must take it, and the numbers are about 25% women, which means women doesn't like C++. I don't know. At least this is the finding here. This was chapter 3. It was short. If you have any question about the syllabus, about the curriculum, why don't you teach them that? What about this? Why do you teach them C when you should not teach C when you are teaching C++? I'm just, having the opportunity of Kate Gregory being here. So I don't teach them C, but they do use pointers here. And I do not start with smart pointers. I'm starting with constructors, destructors, allocations. Why? I don't know, because I think that this is the building blocks, but then we see smart pointers and we see containers, and eventually they should know that the rule of 0 is our goal in life. Any questions? Okay, I think that we go to the next chapter, chapter 4. Chapter 4 is about the exercise itself. Let's talk about exercise. I think that you are here out of curiosity about what was this exercise that you are talking about. So the exercise was implementing a container for a container ship. Now, the first 3 exercises were to implement the algorithm for the stowage of the ship. I mean, how to locate the containers in order to have an efficient load and unload all over the ports that the ship visits, okay? With multi-threading, with reading data from files, with all sorts of things. And then at the 4th exercise, we went back and said, okay, now we want to deal only with managing the data on the ship. And we want to do it in a very organized way, not in a freestyle like you did in the previous exercises, where you only had to implement, the algorithm there was more important. Now, the implementation of the container is important. So we had requirements on how we want this ship to look like. And eventually a ship is a 3-dimensional container for which there are locations on the ship where you cannot put more than X containers. I mean, there is the height of how many containers you can put on each position, but there are certain locations on the ship where, well, we have restrictions. On this position, you can put only 3 containers. I mean, one on the other. And there, you can put the entire 20. So eventually, it's a container with restrictions on certain points. And if you think about that, each position on the ship is some kind of a stack. So it's a vector of stacks, or a vector of stacks, something like that, okay? Now, we may take a look at the actual requirements. So, luckily for me, it was written originally in English, not in Hebrew. So this is the actual exercise. We're looking at the actual exercise that they got. So this is the requirements, the same picture that you see they got. And then comes some explanations about the constructor that we want, about loading a container, about unloading a container. We are not talking about the actual data structures that you have to manage. Why? Because it's your own decision. We are talking only about the API. And in the API, we also have views. I can ask you for a view. And a view is something that, okay, I want a view of all the containers that should be unloaded at, does Bristol has an operating harbor? Should be unloaded at Bristol, okay? So, okay, each container knows where it should be unloaded. So I have a view, and this view may change because, oh, this container moved. But I know that because it's a view, in a way, and I want you to preserve the knowledge of. And you can also have lambda being sent off. The lambda creates the view. I mean, I want a view of all containers that are, give me a lambda and I will give you a view of they add to implement these views. Okay, so we have some usage examples, like it is not a G-test, it's like, a main that shows what we expect. Later on, by the way, we did give them G-tests. So since the exercise checker created G-tests in order to check their submissions, we just gave them, not all of them, because we have to surprise them with tests that they didn't think of, but we did provide some of the G-tests. So this was 3 pages, I think, 3 pages exercise. No, 5, sorry, 5, because there is an image there. So 5 pages exercise, again, API. By the way, on the day they got it, it's a black day. It's a very bad day. But then later on, they read it again, and they see that it is not so bad. Then they read it again, and they see that it is bad. But eventually, they got the example. And when they got the example, I think that they felt a bit better. Any questions about the exercise? This was chapter 4. Do you want 10 minutes to try and implement that, and then we can talk about that? No, we would skip that. It takes more than 10 minutes. By the way, I must tell you that I was discussing with one of the students who came by and said, oh, thank you for the semester. Too many exercises, but I enjoyed anyhow. And I asked him, what about the 4th exercise? Did you like it? And he said, he was a good student. Those who come to talk with me usually are those who, the good ones. So he said, it took me about an hour and a half. I don't believe him. I think he counts only the times, only the keystrokes, not the time that it took him to read the exercise, to read the example, to understand what he is going to do. But, in his mind, he said, I would tell you how he approached that. He said, I just took the example, and you would see the example in a moment, and started changing it till I got to the API of the actual exercise, which would be what I would have been, what I've been doing if I have this exercise. I mean, it's quite easy. I mean, from here to there. So let's talk about the example. So the demo project. What would be the demo project that you would give for this one? How can we help them, but without actually implementing the exercise?
A train, probably. Having a train of containers come in.
A train of containers, that's good. That's good. Instead of a ship, a train. Or maybe a truck. A truck has only one single container. This is too easy. So, in fact, reducing the problem from 3D to 2D. Yes. So it can be a train of containers. We took another approach. We took exam hall. So we have a 2D container of examinees. Now, in the exam hall, you can either have an examinee sitting, taking an exam, or the seat can be empty. And you have information on the examinee, the hall, the exams. Maybe they are taking different exams. So I want a view of all the students who are taking now infinite math or something, okay? So I want a view of all those who, which is similar to the sheep question. So taking it from 3D to 2D, that's all. This is the link to the requirements. Let me check that. It would be, I think, the same 5, because what I did is just, went through the same thing. Oh, it went down to 4. Went through the same thing, and then, rewritten it to be for the exam hall. So this is that. And let's take a look at the provided solution, okay? I think that's important because if we understand the provided solution, then maybe I can actually give you 10 minutes for, or an hour and a half. So they got a single file in CoreCpp, an online compiler. So it actually runs, no G-tests, but a main. And inside, there is the entire thing. With strong types. I want them to use strong types. You need X and Y. I don't want you to get X and Y as size T. I want you to get the X position as X. So you would not mix with X and Y. I want strong types. So they got strong types. It was in their requirements, and it was also in the solution. Did they use it? Most of them, not all. So we have named type as a strong type. We actually implement hash function. They need it as well. But eventually, if we take a look, not at the views, not at the iterators, they add also to implement iterators, okay? What I want to take a look is at this one, line 101. This is my container. And the container is a vector of optionals. That's it. A vector of optionals. I can do a vector of vectors, but there is no need for that. So a vector of optionals. What should be their transposition? What should they do in order to, okay, now it is 3D? What would you do? Change the optional to stack, yes, or to vector. Because there was a need for a random access. Does stack has a rectangle brackets operator? I don't remember. Anyhow, a vector of vectors is fine as well. Anyhow, the idea is, in the positions themselves, I do have a stack of containers. I have another thing. I have restrictions. Restrictions were not in the exam hall demo. Restrictions are, or on a certain position in the ship, the height, the optional height is only 7, not 10. Okay, so when you put containers, if you are above the capacity, I want to get an exception. Yes, that's an addition. This is why it took him an hour and a half, otherwise it would be shorter. So there are things to add, but the basic change is to change this line to something that can accommodate 3D, can accommodate also the height of the containers. So I would not go through the entire code, but we did go through the code with the students. It's not that we just gave them the example and said, okay, there is an example, this is the link, enjoy. We actually went through the example in class, analyzing the example, understanding the example, letting them ask questions about the example, including questions on, I see that in the example you are doing it like that. Does it mean that in the real exercise we can do like that? They could relate it to the actual exercise. Which means you can ask me anything. They did. They asked. By the way, we had a forum, so it's not only in class. And then we came to the actual results. But before that, any questions on the demo project? this is the end of chapter 5. The demo project was a 2D. So let's continue. Chapter 6, defects and failures. Now that we understand the two models, we can see things and say, would I do the same mistake, or this is only for juniors? So first, before, we asked them in the survey, did you use the example project? Now, it was not anonymous, so they may think that they need to answer yes, but they are Israelis. Israelis are quite frank. I mean, they can say, it was a bad course. They can tell me that. They can say, I didn't use the example, it was a bad example. They didn't say so, so I believe them. They actually used it, okay? So, by the way, it was not anonymous because we gave them some bonus for answering the survey. This is the way to get surveys from students. So, they answered the survey. Did you use the, it's not till the screen, now I know that. Did you use the example? No, nobody said no, okay? Yes, I used it and I worked directly on the example code, 34%. Yes, I copied relevant snippets, 49%, and partially, 16%. So, yeah, they used it in several possibilities, several options. Was the demo project helpful? 90% say yes, it was helpful. And you see that they are quite frank. I mean, at least one said, oh, it was not helpful at all. Oh, not so helpful, sorry. Not helpful at all, nobody. I mean, I think that they actually understood that, yeah, it gives us most of what we need to do. So let's categorize the mistakes that we found. And again, I would tell you that we were a bit surprised because some of the mistakes we said, but why? So, not using code or principles from the demo project. It was there. Why didn't you use it as is? Ignoring demo project inadequacies for real project. I mean, yeah, it was in the demo project, but it was for the demo project, not for yours. Other mistakes. Yeah, there are other mistakes, not related to the demo project. I mean, yeah, you can do your own mistakes if you want. So let's start with the not using code or principles from the demo project. Let's take a look at this one. This is from the demo project. Remember the strong type? It was there. It was there. They knew that they need to use it. Why they knew? Because it was in the API. The API required that when I approach the ship, I talk with you with X and Y, not with size t, not with integers, with strong types. So, yeah, we need strong types. And we got the strong types in the example. But instead of using the strong types the way that we created, not all, I would even say not many, but quite a few, created their own versions. This is one of the versions. That were all sorts of versions of their own strong type, which is not a strong type. Type def is not a strong type. If you need, go to, there was a talk today or yesterday on strong types. Anyhow, look for strong type, Joe Bocara, or other libraries on strong types. Why did they do that? Well, when we didn't interview them in this research. When we try to understand, most probably is that the reason is that they didn't quite understand why this is better than this. So they tried to simplify. I mean, let's make it a bit more simple, but yeah, you're losing the actual value of strong types. So trying to amend the example where you should not is a bad thing. And why juniors do that? Because in some cases, they do not understand the example. They could have asked. They could have asked, but they didn't. Or they did, but you know, they didn't get the answer. Didn't understand the answer. So they just changed the code. Okay, next one. Oh, this is quite small. I would tell you what I see here. So on this side, this is the demo project. How can I tell? Because I see examinee over there. On this side, I have the ship. What can you see about the way they implemented the ship? Oh no. Oh gosh. What did they do there? Three-star pointer. Pointers. Why do we teach them C? We should avoid. They are doing so much damage. So yeah, let's do some allocations. And of course, when they did allocations, they forgot either to implement a destructor or to block or to implement the copy and the assignment. I mean, if we are doing it wrong, let's go all the way. This is what they did. But you know that we prefer the rule of zero. We talked about that in class. And you saw that in the example. And we talked about the example in class. Why did you do that? I don't know. It seems that, you know, we need here 3 dimensions. So I thought about, well, stop thinking. Next one. This is the ship. How can I tell? Because I see bad ship operation exception above. So we have the ship. What do we see here? We have a load and unload. This is the ship. The ship means their own exercise, right? Anything bad that you see in their implementation here?
Can you give me a minute? I'm still reading.
Yeah, I would give. I would just explain. They need to implement a load into the ship, a load of a container into a position on the ship, and unload. Unload means give me the top container from a position. Load, put me a container on a position. Let's do a code review. Okay, let's start with the first comment that you may have. Yes, a comment. You say that they are using exceptions for something which is logical and not a bug. Oh, it is a bug, you say. So if it is a bug, maybe exception is okay. Yeah, so no? Okay, I think here it's a discussion. Anyhow, there are cases where bad access throws exception, vector at. So bad access, throwing exception, yeah, I think some others got this. By the way, the demo project did the same. So I can't argue that they did something wrong, at least I did the same. Personally, I don't have an issue with throwing an exception in this case. I would start with code duplication. Cannot you see the code duplication here? They copy-paste. They copy-paste. We should turn off this control key from their keyboards. They copy-paste all the time. Even though in the demo project there were helper functions. They saw that we are using helper functions. No, we do not need helper functions. Copy-paste is easier. So we can see copy-paste from the if there to the if here. Well, another thing that I can show you is that, do you see the stud move here? The stud move down below in the unload? What do you say about the stud move here? Is it legit? Is it in place? Or is it a bug, this stud move? Okay or not okay? It's complicated, stud move. Should we do stud move here or not? I mean, I need to unload something from the ship. Anybody who thinks stud move here is fine? Anybody thinks stud move here is bad? Nobody, a few. So stud move here is okay. It's okay. It was a tricky question. Why? Because I just pop back. Okay, I'm going to pop it out of the vector, so I know that it can be invalidated. The issue is not here. The issue is here. They do not use stud move here. And they get by value. Why did they get by value? Because this was the API that we gave them. The API required to get by value. Okay, this was the API. But if you get by value, and you saw that in the demo project, when we got by value, we stole. I mean, we moved. So you could have still moved from the container that you got by value. Why didn't you? Because stud move is difficult. Okay, that's reasonable. You did remember to do it here. Yes, because we did quite a similar thing in the demo project. Okay, so this is how it was done in the demo project. Not the exact same thing, but again, using, there is here some kind of helper function instead of asking the if in the function. It is quite nicer than that. Well, it is less complicated to begin with, but at least what is there could be used, and it was not. Another one. What's wrong here? It's not so bad. Yeah, just return the result. Simplify Boolean, it is called in most static analyzers. Simplify Boolean. I mean, you are just going to return a Boolean, so why the if? Just return the expression itself, and that's it, right? Now, in the demo project, we add similar things, and we returned expression in order to return a Boolean result. Okay. In class, I think that they saw that we are not doing that. Maybe they got feedback on similar things, but you know, it's quite complicated to get good practices from example, because it's not that, oh, I see how it is done here, so I would do the same. No, when I have to type my own code, I type my own style, and my style is that. So what is the best way to know to avoid that? What would make them avoid that? Minus 1 point in the exercise grade. That's it. Yeah. Usually I tell them that, you know, it's not so bad. I even would not reduce any points for that. But if I would not reduce any points, you would keep doing that. So I don't have any other choice but reducing at least 1 point. So they say, okay, I understand. Yes?
In this case, there's a stylistic thing that I really don't like. You have an if condition that calls a function called validate restrictions, which says that it's validating restrictions.
Oh, you don't like the name. So
that's perfectly fine.
Okay.
There's an extra check right in front of it that sounds like it's a restriction being validated.
Oh, it's
missing from that function, or
yeah. There is a question here about the split between the check of the height and the check of the validated restrictions. The reason is that the restrictions are the restrictions per position, and the height is the generic height of the ship. So the ship can hold up to 20 containers, unless there is a specific restriction on a specific place. And the idea here is, and you can join the code review panel, can you bring the height check into the valid restrictions? Yeah, sounds right, I would say. Instead of, and then it would be even nicer. Yes, I would take that. Not using code or principles from the demo project, other things, duplicating code that was presented in the demo project in proper helpers. I think that we saw one of that. There were many. I mean, they like to copy-paste. Even if they see in front of their eyes similar thing that was using helper function. Initializing in constructor body instead of in constructor initialization list. But you saw that we initialized in the initialization list, and we told you that in some cases it is more efficient. Yeah, but they did initialize in the constructor body. Looping on a vector to initialize it to zeros for unknown reason, even though we didn't do that in the example. Holding a unique PTR to vector. Why? Inventing new naming conventions. Exposing data members in the public. And using throw instead of no except, even though the demo project used no except. Why? Probably they saw it somewhere else. Ignoring demo project inadequacies. Oh, we should have changed that, and we didn't. What's the problem here? You can see that above is the ship, above is their solution, below is the demo project, below is the examinee all. What is the problem? There is no need for the optional. I mean, the optional can go. And they should understand that once you go to a stack, I mean, at a certain position, a stack can be either empty or as, now with this solution, the design is quite flowed in a way that you approach each position on the ship like, you know, like you can add a container on the air. I would just want to, so they use the vector for the 3D, they just, you know, like I did with a 2D, and then at a certain position you may have a container or not. And then in some cases, I mean, when you need to load a container, you have to loop on certain, in order to understand where should I put it. Well, you should have a vector inside instead of optional. Anyhow, the optional is not the right design. And this is complicated. I mean, the optional was there. I did what the demo project presented. This is quite tricky. Not many. It was a few. But when I saw that, I said, I couldn't think of this mistake. I mean, but I understand why they did that. And why is it important? Because when we work with juniors, in some cases we give them a task. We come after a day, and we see something which we say, how could you think of such a solution? I wouldn't think of that. I didn't tell you not to do that, because I didn't think that you can do such a thing. Think about anything. They can do anything. I mean, you should tell them, you see the optional, it's relevant for the 2D, it's not relevant for the 3D. Discuss with them. What is your design approach? Before sending them to code. I mean, otherwise you would spend a day, 2 days, a week, and then you would get something that you need to throw away. Another one. This was in the examinee. How can I tell? Because I see the namespace exams. Okay. What do I have here? I have an example of a bad exception class. And why is it a bad exception class? Because it just prints something in the constructor. Why did I do that? I don't know. I am doing, strange stuff as well. It was there. It was just in order to say, yeah, we need to take care of exceptions. And I think that while presenting it to them, I said, orally, listen, I don't expect you to print inside the constructor of the exception. It is just because I was lazy. This is not what you need to do. You need to actually create an exception that can give you a message. How can I tell you that I just recall saying that in class. How can I be positive that I said it in class? Because most of them did it correctly. Most of them did change the exception. I got a real good exceptions. But some of them left it like that. And then, can I say something? Well, I can. I told you that this is just an example. I mean, you should implement it as it should. So, another one. This was in the testing. I prepared some testing. In the testing, I showed this is the exams. Okay? Oh, there is a seat. The seat is being taken. You try to seat somebody on a taken seat. The exam does not allow students to sit on the same seat. So we throw an exception, okay? What did they do with this example? And then I try to understand, why do you do that? Oh, because you saw that in the example. What did they do in their actual solution? They swallowed exceptions. Well, I'm swallowing exception here. Well, I'm swallowing an exception here because it's just saying that this is a test. I want to seat somebody, and then I want to seat somebody else on the same seat, and then I expect it to throw an exception, and I'm saying, okay, the test passed. I mean, it was not in the G-test, it was in main, but this is what I was trying to convey. So they saw that, and they used the same idea, not in their main, not in their tests, in their actual code. So in the actual code I saw, not all of them, but too many swallowing exceptions. Why? Well, the teacher showed them how to swallow exceptions. Well, it was in another context. Yeah, but context is complicated. So I didn't think about that. I didn't think about saying to them, this is just a test. Usually you do not swallow exceptions. I didn't think about that. But you have to think about that. Otherwise you would find it in your project. Other mistakes not related to the demo project. Some of those who allocated memory, as said, forgot destructor or forgot to delete or to implement the copy and the assignment. which they knew they had to do. I mean, I would reduce points for using allocations. But, you know, reducing 10 points is better than reducing 20, so maybe it's better to come with a distractor. Const correctness, all along. Const correctness. They don't like const. I mean, sometimes they like, sometimes they don't. Now, in the demo project, we tried to be quite, you know, as we should, to put const as should be. They didn't do that. I mean, some of them. StudMove. StudMove was used occasionally, not always as it should. So we had inefficiencies of not using StudMove where you need, and actual bugs. Using StudMove where you shouldn't. It's complicated. I mean, to understand, am I still using this thing or not? And here it's quite complicated because the thing is not an actual R value. It's a container that is being removed from the ship. So in some cases you should StudMove it, and in some cases you should not because it still lives on the ship because it's a view. It depends. Unnecessary copies, redundant copies. I'm looping on something with auto and not with auto ref. Why should you loop with auto and not with auto ref? I don't know, it's just a ref. I can leave it or not. No, you are copying the entire container. Code duplication, all sorts of algorithmic inefficiencies. You had to loop over the view. I mean, you had to find the view. There are ways to do that. We didn't, you know, look for the best algorithmic complexity, but when somebody implements cubic complexity for something simple, it doesn't look right. And implementation that doesn't fit the requirements. I mean, there was API. The tests were relying on a certain API. If you're coming and the API doesn't fit the API that you got in the requirements, we cannot test you. I mean, we eventually would send you back the exercise, ask you to align, otherwise we cannot test it. But not all of them went through the requirements as they should. This is the end of chapter 6. Any questions on that before we go to some analysis? Any questions or comments on the defects that we saw here? Any defects that you were thinking to see and I was not talking about? Because there were other defects, I can tell you. Oh yeah, we had that as well. Off by one. Yeah, off by one, I guess that we had off by one, yeah.
Okay, I guess I'll go first. Looking at this and knowing that you did a C course before this, how many of, or what kind of percentage of this would you say is caused by teaching C first?
So, the fact that they knew C before, what was the impact? Maybe going for 3-star pointer, 3-dimensional pointer was impacted by learning C. I don't know. I really don't know. But I would tell you that they knew that they are in a C++ course. They knew that they would be graded on the quality of their C++ code. They knew that rule of 0 is important because I told them, go with rule of 0. Even when presenting the exercise, I told them if you can avoid allocations. You do not need to open the entire toolbox and use all the tools. Use the proper tools. I mean, in some cases, you see students that open the toolbox and want to use all the tools. No need, right? I don't think that there is polymorphism here in this exercise. Kate. Kate asks quite loudly, but a mic could also record you.
Do you think by and large they thought their code was good? Like, did some of them just go like, time's up, I'm going to hand this in, I know it doesn't meet the requirements, but I'm fine? Or were they all like, oh, I nailed it, and then they were mad when you didn't like their 3-star general activity?
So I would try to summarize the question, and you would tell me after I would answer the question that I think was asked, if this was the question. would they stop? Did they stop when they think that, okay, I think that I have something good, and maybe this is the reason for not having a perfect exercise, or is it something more deep? So first, yes, there is a time issue here. I mean, they are trying to manage their time. First. Second, there is a sentence that I'm saying to my students always. Working is better than fancy. Working code, as long as it is in C++. Don't submit something in Python, right? But working code is better than unworking, good, fancy C++ code. Because eventually, the major part of your grade on the exercise would be passing the tests. So I think that they tried to pass the tests, which is good. This is what I would expect from them. This is what they would be expected in the industry. It relates, by the way, to the talk of Phil Nash, doing it right or doing the right things. So I think the right thing is to be on time with something that you can deliver. Okay, then we would subtract some points on this and that, and you still would get 90. But coming with something that doesn't work, you would fail. And I think having that in mind, which is good, they try first to have something working. I argue that once you have the example, well, you can have it both working and, implemented right. But it seems that I was too optimistic. I mean, I would say that most of the class were good. We're good in the 90 and up, 90 out of 100, right? But there were too many of a quite good class that did all sorts of these embarrassing mistakes.
Sure. I mean, the reason I was asking, code duplication, they could be unaware. Whereas, I never take the last container from the stack. I stop when there's 1 and I should go till there's 0. They should have known, right, that they had a bug?
So I think that most of the exercises got good grades on testing. I mean, when we tested them, they passed most of the tests. They got some of the tests up front, so they could check themselves. They prepared more tests. They shared between them their own test. Oh, I have tests. They uploaded it to the core site. So yeah, they invested in testing it, so they had quite working exercises. So I think the message out there is that there are good programmers. I mean, we would find them in the industry and they would do fine. But still, they are juniors. That's all. It's not that we kick them out.
Thank you.
Any other comment or question? So I think that we are on our way to chapter 7, which is the last one. Conclusions and recommendations. So what would we do? In the paper, we discussed the Bloom's cognitive taxonomy levels. It's a very known model in psychology, in educational psychology, of you need to teach something, there is knowledge, which is quite easy. Okay, you know that, I don't know, Bristol is in the UK. Then come more sophisticated levels. And what we presented in the paper is that their mistakes are spread over the entire Bloom taxonomy, which means that they had both mistakes that are just knowledge. You had to know that. So either you didn't know, or you just forgot, or you didn't have time. But it's not too much thinking. I mean, when I tell you, but what about deleting the copy constructor? Oh yeah, I know, I forgot. Oh yeah, I didn't have time. So this is the knowledge, which means either you knew that but forgot, or you did not, but I mean, there is nothing here to comprehend. On the other side, understanding that the optional should go requires some kind of evaluation. Understanding that I should have a better design. And seeing that the mistakes are spread across the taxonomy, I mean, they are on different levels of cognitive burden, cognitive levels, means that giving an example is still good because it still allows the student to have the challenge of actually thinking. I mean, he still needs to think about the design. He still needs to think what he should take from the example and what he should change. So this is, I think, a good result. Suppose that we would see that all the mistakes are quite small, minor mistakes. It would mean that we didn't give them enough space for actual thinking. And it seems that they add enough space for actual thinking. So in order to provide a good exercise, they had to think, which is good. And it means also that in actual life, in order to actually take an example, we need to think. It's not just, okay, I got the example. Give me 5 minutes and it's done. No. Using code examples is harder than it appears. Requires practicing, special attention in code review too. What is the code supposed to do? How is it tested? You should ask, okay, I understand that you copied these lines. Did you test them? How? Does it fit our design and coding conventions? Is the license approved? And if you were asked to put your name on this piece of code, it's the word code here, would you put it? By the way, putting author tag on code. People stop doing that. Google style guide advice is not to do that. I do preach for keep putting author tag on function, on new thing that you did. Why? I have 2 reasons for that. First, in many cases, the contributor in the source control is not the actual contributor because of private merges and integrations. So you think, oh, I see that the last one, no, he just took it from here to there, and you miss something. Maybe it's in the tree. You can analyze that eventually, but it might take time. Seeing a name inside, yeah, it's this guy that left just 1 year ago. So it's easier to understand. It's not necessarily always right, but it is additional piece of information. The other reason is that it adds sense of responsibility. I mean, in code reviews, in some cases I say to the person writing the code, oh, it's a good function that you added here. Let's put your name on the function. And then he says, I don't feel so. Why? If I put my name on that, I need to test it a bit more. So test it. This is what stops you from putting it in the source control, putting your name. We would know that it is you. So in some cases, you know, the pride of, I put my name on that, means that I believe it's good. This is a picture I taken from an architect that was, or a builder that was proud of his building. You can check later where it was taken. Anyhow, somebody can say, but it is, I don't know, maybe I like this building or not, but he liked it, so you have to be proud of your code. And for that, I believe that asking you to put your name, again, it is, but I took these lines from the internet. So, put a comment. The lines were taken from, amended by, I did this and that. Okay, I want to see that. Because without that, I mean not for a single line that does a very simple thing, but you took an algorithm doing something quite complicated. I want to understand. I want your name there. Generous approach to problems to be aware of. To be aware of and to beware of. This is the last part, I think. So, let's not ask. It may show we don't understand. Did you meet this issue? He gets the assignment. She gets the assignment. They get the assignment. And they just nod. Are you okay? Yeah, sure. Do you know what you should do? Yeah, we're typing, we're doing. At which stage you are? At a good stage. When would it be done? Oh, I think tomorrow. I can answer you that. So, they don't like to ask. So you need to check them. They, in some cases, would not raise flags. And then they say, it's good I didn't ask. I got it done on my own. Yeah, there is some kind of modularity here, and I think that I got on the idea of the modularity. There are a few parts, and I put them together. Yeah, I think that we can use that. It fits the requirements, I think. Yeah, it might. By the way, maybe it does. Maybe it does fit the requirement, but your responsibility is not the requirement, is making something usable, using your common sense. What's so bad with some undefined behavior? I think I got it right now. I think I fixed it. Keep calm. We are not far away from the end. I think I fixed it. Now, we actually see it in code. Okay, it's funny, right? But when we see it in our own project, we usually do not laugh. I mean, we laugh, but after we spend a few nights on doing it right. I think I got it right now. Oops, something is broken. Let's document it. So someone would take care of it. It says down below, please do not have an emergency at this location. But I documented it. I know it doesn't work, but there is a comment. I wrote it in a comment, it doesn't work. Comment is not enough. It should be, in the list of known issues that we provide with a release. And then, again, it should be discussed before, not at the last moment. Let's put things in the public. Transparency makes things more accessible. Yeah, they come with these ideas. It would be easier, in a way, to know whether there is somebody inside. That is almost all. Any questions before we conclude? Yes?
Yeah, just a remark, I would say, about the putting your name. The things that the juniors that go in companies are actually integrated part of a team. And when you are part of a team, actually, it should be a teamwork when you are doing a task. So it should be with code review and everything. So every piece of code, even if someone is actually the one developing it, has been accepted by the whole team. So I think it looks like a finger pointing, putting an author on, hey, it's his fault, while actually someone else or even team validated actually his pull request. So except if he force push on master, then it's a DevOps the problem. I don't think it's actually a good thing to do.
Yeah, so there is a comment here on, well, it's a teamwork. Usually it's not a single developer, so putting your name is maybe considered as bragging, or it's not yours, why I see your name there, or misleading. So again, it's not that we would do that always. In a way, I'm using this approach for understanding how the other side feels about the code. There is a story, I think, told by Joel Spolsky about his code review in Microsoft. He wrote about his first code review, or one of his code reviews, when Bill Gates was coming to code reviews. He said there that Bill Gates was about 5 levels above him. Nowadays, for a developer, it would be 20 levels. The CEO would be 20 levels above, but in these days, it was about 5 levels. And then he came to the room for the code review, and he saw that Bill Gates is coming with a piece of papers and a lot of red ink on that. So a lot of red comments, so he was a bit afraid. And then they sat, and then he asked him 2 questions, and after 2 questions, he said, okay, it's done. I'm fine with that. And the questions were about, it was in Excel, and the questions were on a certain thing with the date function in Excel. And it was on a very narrow point that he wanted to see whether the other side is did it right and knows about the thing. I mean, feels secure with what he implemented. So one of the things, I mean, this is not code review. I mean, you need to do more than that, but this is a story. Joel Spolsky is a developer, is the founder of Stack Overflow, and he's a storyteller. So this is a story, but it comes to say that in code review, it's not only going through the code, it's understanding whether the other side actually feels secure about the code. Otherwise, if it doesn't, stop the code review. By the way, one of the questions that I asked at the beginning of a code review is, did you test it? Did you test it? Because I don't want to perform code review on something that was not tested. It's a waste of time. Come after you pass the tests. And if the answer is no, not yet, I didn't have time, so come after doing the tests.
I just wanted to add a small thing to that based on the experience I have within the company I work at. We have a large monorepo in one case where we have groups of people responsible for parts, and we have a couple of hundred repositories with different teams. And in all of those, there is a notation at the top of a tree that somebody's responsible for, who the code owners are for that bit. And that is basically taking the ownership and showing pride in that being the part that you're responsible for.
Sounds good for me.
Which is the same functional thing, but it's not polluting your source code.
Sounds good for me. Again, it might be your name in Git. It might be, anyhow, don't, like for example, don't submit your code through another developer. I want to know that you wrote it. Oh, but I'm not sure he wrote it, so I prefer to... No, you are submitting, you submit through your account.
I'm just a bit curious about your point of view as a teacher. Some schools are switching for systems programming from C to Rust. And with the problems that you showed today, do you think Rust would be a better language for teaching? Because the compiler already warns you for a lot of those things, mistakes that you presented today.
Okay, so the question was about moving from C++ to Rust, and it was narrowed specifically for teaching, because this is a broad question of moving from C++ to Rust, also maybe in the industry and in other domains. By the way, I have a blog post in Incredibuild blog site on Rust. If you look for that, on comparing C++ and Rust, I have a shirt that I am coming to. I was with this shirt one of the days here in the conference saying, I love C++. So I'm not so objective on this question. I'm teaching C++ for many years, but in a way, let's start with many institutions went not to Rust, to Java, to Python. You can today graduate from with a CS degree, knowing a bit C, maybe, some assembly, and Java or C# and Python. And with that, I have a problem. I'm not the only one seeing it as problematic, but this is the case, right? By the way, those who didn't take this course know some C, but they go to the market without seeing C++. Okay, because it is a non-compulsory course today. By the way, again, Joel Spolsky has a very nice blog on the subject. I would reach Rust in a moment, called The Perils of the Java Schools. Do you remember, anybody read about the perils of the Java schools? He grants about, oh, when I was a student, I had to write with zeros and ones. And I was lucky, because the generation before had to write only with zeros. Anyhow, he grants about that. You can read about that. Rust. I think that Rust is good for teaching, because in a way, it has the ideas that you have in C++, so it's a system language. You could do things that can be done in C++ with Rust. Industry is taking that. And then comes another question. What is the reason for teaching C++? I see the reason as not only having object-oriented language with the ability to reach the underlying memory, efficiency, etc., but it is being used in the industry, which is very important for CS undergraduates. I mean, you go out to the industry and there is demand for C++ developers. There is a little bit less demand for Rust. Nowadays, it may change. So if it is my decision, I would prefer to see more C++ developers out there, because we need them. This is my answer for that. Yeah. I answered another question. You want to...
Yeah, you might have misunderstood me a little bit. I just meant the replacing C with Rust.
Oh,
you
replacing
still have a C++
C.
course.
Okay.
Yeah.
That's interesting. Well, the syntax of Rust cannot serve as a base for C++.
Yeah, of course.
So if it is Rust and that's it, again, I think my answer still stays. If it is, okay, we start with Rust and then you would do also C or you would do also C++, so I would say, okay, it's another language. By the way, my advice to students come to me in some cases and ask for advice, should we take Java and C#? I mean, they can take it, and then they would not take like image processing. And I tell them, take one of those, doesn't really matter which, and take image processing. I mean, don't invest too much in languages. You should get out with 2, 3, and with actual knowledge. So don't do 5 languages, do 3. This is my answer. And then my 3 would be, I guess, Python, Java, C++. But I don't know, this is my answer.